Thomas Young was trying to win an argument. It was 1801, London, and the argument was with Isaac Newton, which, dead or alive, is a genuinely terrible idea. Newton had said light was made of particles, little bullets, corpuscles, he called them, which sounds like something you'd find in a Victorian medical textbook. But the point is, particles, discrete, definite there. Young disagreed. So he did what scientists do when they disagree with someone. He built a thing. 2 narrow slits cut into a card, a candle on one side, a wall on the other. He shone the light through and looked at what landed. If Newton was right, particles, bullets, you'd get 2 bright lines, one for each slit. What Young got instead was a zebra. Alternating stripes of light and dark, spreading wide across the wall. The kind of pattern you only ever get from waves. Ocean waves, sound waves. When 2 waves meet, they stack or cancel depending on timing. And what you get is exactly that striped pattern, an interference pattern. Light is a wave. Newton was wrong. Young was right. Done. Except it wasn't done. Not even close. Jump forward to the 1920s. Physics has just finished being completely disassembled and rebuilt from scratch. Einstein's done his thing, Planck's done his thing. And somewhere in Copenhagen, a group of physicists has started doing something that, in retrospect, seems almost criminally reckless. They've started applying quantum theory to the double slit. Here's where it gets genuinely weird. Not textbook weird. Actually weird. You can fire electrons through the double slit instead of light. Electrons, actual particles with mass, with charge, with everything you'd need to call them a physical object. And if you fire enough of them through, one at a time, slow enough that there's no possible interaction between them, they still make an interference pattern. A single electron by itself, with nothing to interfere with, produces a wave-like striped result on the detector screen. Which means, and here's the part that should break something in your head, each electron must somehow be going through both slits at the same time, interfering with itself, a particle in 2 places simultaneously, producing a wave pattern, landing on the screen as a single dot. Richard Feynman, Nobel Prize, famously not a man who oversold things, said in 1965 that the double-slit experiment contains the only mystery of quantum mechanics. Not one of the mysteries, the only one. Everything else, he said, is just a variation of this. Fine. Weird. Moving on, except here's the thing that turns weird into something else entirely. Someone, at some point, had the bright idea of putting a detector near one of the slits. Just to watch. Just to see definitively which slit each electron goes through. Because if we're going to say electrons go through both slits simultaneously, someone needs to actually check that. Right? Scientific method, observation, evidence. The detector goes up, the interference pattern disappears. Not weakens, not changes shape, disappears. The moment the experiment is set up to record which slit the electron went through, the electrons stop behaving like waves. They go through one slit or the other. Like particles. Like they're supposed to. Like Newton would have expected. 2 lines on the screen, no stripes, no interference. And then, this is the part that should keep you genuinely unsettled. You can turn the detector off again without changing anything else. Same electrons, same slits, same screen. Just remove the observation. The interference pattern comes back. The electrons somehow know whether they're being watched, and they change what they do based on that knowledge. Now, let me be very clear about something, because this is where a lot of pop science explanations take a wrong turn and never find their way back. The observer effect does not mean consciousness causes quantum collapse. That's a leap too far. The New Age section of the bookshop has been running with that idea since the 1970s. And it has caused more confusion than almost any other misreading in science communication. What the detector does is interact with the electron. Any physical interaction, a photon bouncing off it, a magnetic field nudging it, counts as observation in quantum terms. You don't need a person watching. You need information to exist somewhere in the universe about which slit the electron went through. That's what causes the collapse. Not your awareness, information. And here's the genuinely disturbing thing about that framing. It's almost worse. Because it means reality isn't waiting for a conscious mind to make it real. It's waiting for information to become available anywhere. To anyone, to anything. The universe is apparently running a tab on what is and isn't known, and it adjusts physical behavior accordingly. There are currently, and I want to be precise here because this matters, at least 17 mainstream interpretations of what quantum mechanics actually means. The Copenhagen interpretation, which most physicists use in practice, basically says, don't ask, calculate the probabilities, predict the outcome. Don't ask what the wave function actually is or what collapse actually means. It works. Stop picking at it. David Bohm in 1952 said, "No, there's a real particle following a real path, guided by a pilot wave we can't see. Hidden variables. Determinism preserved." Hugh Everett in 1957, the man who gave us the many worlds interpretation, said, "The wave function never collapses. Every possible outcome happens in a branching universe that splits every time a quantum event occurs. Every electron goes through both slits, in every version of the experiment, in parallel worlds that can never communicate with each other. Which means, if Everett was right, and he might have been, we genuinely can't rule it out. There is a version of this universe where you didn't click on this video. Billions of them. A version where you weren't born. A version where the experiment was never run. A version where Thomas Young lost the argument, and we spent another century thinking light was made of bullets. All equally real. All equally happening right now. Here's my actual position on this, for whatever it's worth. I think the Copenhagen interpretation is cowardice, dressed up as pragmatism. It works, yes. It produces correct predictions, yes. But don't ask what it means is not a philosophy of science. It's a philosophy of filing things away and hoping nobody comes back to look. The many worlds interpretation is probably the least insane of the remaining options. Not because parallel universes are a comfortable idea, they're not, but because it's the only interpretation that doesn't require you to smuggle in some unexplained collapse mechanism that nobody has ever observed directly. But here's what I'm actually convinced of. After everything, the double-slit experiment is not a mystery we haven't solved yet. It's a mystery we solved, didn't like the answer, and have been creatively reinterpreting ever since. The answer is that particles don't have definite properties until they're measured. Not just that we don't know what they are, that they literally don't have them. Position isn't a hidden truth waiting to be revealed. It's created in the act of measurement. That's not philosophy. That's what the math says. Bell's theorem in 1964 proved it. The experimental tests, Aspects experiments in 1982, every refinement since confirmed it. Local hidden variables are ruled out. The electron doesn't secretly know which slit it went through all along. It genuinely didn't go through either. Not until something asked. Stand in your kitchen right now. Look at the worktop. It's there. It's solid. It has a color. Now consider that every atom in that worktop is made of particles that have no definite position until observed. That the solidity you're experiencing is an emergent property of quantum probability clouds. So dense at the macroscopic scale that they produce the reliable illusion of a surface. Your worktop is real in the way that traffic is real. Made of things that are individually chaotic, unpredictable, going through both slits, somehow producing, in aggregate, something you can put a cup of coffee on. We built nuclear reactors from this. We built MRI machines. We built the transistors inside the phone you're holding right now. All of it runs on quantum mechanics. All of it depends on a theory whose implications nobody fully agrees on. We are engineering with something we don't understand. Thomas Young wanted to win an argument in 1801. He did. Newton was wrong. Light is a wave, except it's also a particle. Except it's neither until you look. Except when you look you change it. Except it doesn't matter whether a person looks or just a detector looks. Except the detector has to be made of particles that are themselves subject to the same rules. The argument Young started in 1801 is still going. And the longer it goes, the more I think we're not getting closer to the answer. I think the answer is that there isn't one. Not because physics failed, because the question, what is reality made of, underneath when nobody's looking, might just be a question the universe has specifically designed itself to refuse.